Okay, so to look at the molecular formula, in order to determine it, we have to look at essentially the empirical formula first. Okay, so to determine the unknown sample identity, this actually is quite useful in a lot of different fields of science, anywhere from environmental chemistry to forensics. Look at anywhere where you may have an unknown sample that needs to be identified. So it could be something found in water, in the air, whatever the case may be. So actually, this is used quite often, even in today's standards. So what we're looking at here, of course, is when you look at an empirical formula, we know that that tells us the simplest ratio of elements. But it doesn't really necessarily tell us the exact number of elements. Remember, that's the actual formula or the molecular formula. So sometimes you'll see molecular formula be referred to as the actual or true formula of a compound. So for example, if I had benzene's empirical formula, okay, this doesn't really tell me much. Is it C2H2? Is it C10H10? Like, we don't know what the actual formula is. So of course, by knowing what the real formula, the true formula for benzene is, that obviously tells us a lot more information. So what we're going to look at today is essentially how can we go from the empirical formula to the molecular formula. So if we have information here, how can we solve for what the real formula of the molecule is? So keep in mind that sometimes the empirical formula will be the same as the molecular formula. So meaning they can no longer be reduced down any further. So here are some, just to give you an example, we looked at, I know, in the last lesson as well. So water, methane, propane. If you look at the ratio of the elements, they can no longer be simplified. However, there are some that it's different. Of course, we just looked at benzene. Here's another example, ethane. So C2H6 can be simplified into a different empirical formula. Phosphorus 5 oxide is P4O10. That can be reduced down. And of course, this is the one that we've already looked at with benzene. So let's talk about how we can go about doing this. So essentially what we're going to do is we need to figure out what the factor is that the empirical formula has to be multiplied by to get to the real formula. So if you remember, we saw this already. So for example, if I have CH, if I solve for the factor being 6, that means that I can get to my real formula by multiplying the subscripts. So the n number, so basically this is like our n, has to be a whole number integer. So you're never multiplying by a factor of like 1.8 or something like that. It has to be a whole number. So you're probably going, well, how do we get the factor? How do we figure out what this n is? How do we know what to multiply the subscripts by? So we need to actually be given the compound's molar mass. We need to know how much does that real formula weigh in grams per mole. So in real life, so obviously this will have to be given in the question, okay? You will have to be given this information. So you probably will, in real life, there's no one giving anyone this information. There's actually a piece of machinery, an instrument that's used to determine the molar mass of a substance, and it's called a mass spectrometer. So mass spectrometers are kind of a rare piece of equipment. You will find them if you continue in science in university. Usually you don't even see a mass spectrometer until maybe second or third year of if you're taking chemistry courses and you continue on. So even a first year general chemistry class, you won't see a mass spectrometer. However, if you continue in year 2, you will most likely see one. So essentially what it is it's an instrument. Just like you can use an instrument to determine the temperature of a liquid, it's obviously a more expensive piece of equipment than a thermometer, but basically it's a piece of equipment that scientists can use to determine the mass of different components that are in a compound. So in real life, you would have to do an experiment to get this. But obviously when we're doing it here, we're not going to have that experiment to do. So we have to be given it in the question. Okay. So in order to determine the molecular formula, we need to have two things. We need the molar mass of the sample, and we need to have the empirical formula. Okay. If we don't have those two things, we cannot figure out what the real formula of the molecule is. Okay, so let's go through what we're doing. So what are we looking for? We're trying to look for the molecular or actual or real formula. What will we be given? So first of all, you have to have the empirical formula and the molar mass of the unknown. Now, you may not be given the empirical formula, but you have to be given enough information that you can solve for this. So remember, we just learned in the last lesson how to figure out the empirical formula. So you may have to actually do this step first and then figure out the molecular formula, okay? But no matter what, you have to be given the molar mass. Okay, so here are the steps. Again, this is similar to before. The steps are not going to make a whole lot of sense until we actually start doing some examples. So the first thing you're going to do is you're going to figure out the molar mass of the empirical formula. So you're going to get the molar mass for the empirical formula. You're then going to divide the molar mass of the real compound and divide it by the empirical formula molar mass. So basically, it's like the molecular formula molar mass divided by the empirical formula molar mass. That's going to give us our N factor. Once we know our N factor, we're then going to multiply the subscripts to actually get the real formula. Okay? So we'll look at an example, and then I'm going to have you try one out. So the empirical formula for butane, which is a fuel used in disposable lighters, is C2H5. So my empirical formula, they're giving it to us this time, C2H5. In an experiment, the molar mass of butane was determined to be this. So the molar mass of the molecular formula is 58, doesn't have a decimal, grams per mole. So they're telling us the molar mass of the actual compound is 58 grams per mole. And we want to know what is the molecular formula. Okay, so the first thing we're going to do, step one, we need the molar mass for the empirical formula, which is given to us. So we have 2 carbon and 5 hydrogen. All right, so we get that from the periodic table. So 2 times 12.01 plus 5 times 1.01. So we get here a molar mass of 29.07 grams per mole. Okay. Step number 2, we're going to take our molar mass of the molecular formula and divide it by the molar mass of the empirical formula. So that's going to give us our N number. So here we're going to have 58 grams per mole divided by 29.07 grams per mole. And it's always the larger number on top because we want a whole number. So we get here 1.995, which rounds to 2. So remember, we're trying to get our N factor. So when you're doing this division here, you can round this to a whole number. Okay, but I'll be honest, if this is done correctly, it should be pretty close to a whole number already. So if you're doing this and it's way off, like it's like 1.5, just double check that you have the correct molar mass. Okay, so step 3 means we're going to take our empirical formula, C2H5, and we're going to multiply by our N factor, which is 2. So that means our molecular formula is C4H10. So really, you're just doing this calculation. So you have to take the molar mass of the molecular formula. This will be given to you, divided by the molar mass of the empirical formula to get your N factor. Okay, so try out this next example. This is a little bit, it's a little bit chill. Okay, I'm going to give you another one to do after this, actually, but try this out. So we have the empirical formula of codeine. So we have codeine's empirical formula. The molar mass of codeine is this. What is its molecular formula? So give this a try. Okay, so molar mass for the empirical formula, right? So we have 18 carbons, we have 21 hydrogens, we have 1 nitrogen, and we have 3 oxygens. Okay, so let's calculate this out. Okay, so we should get here 299.4 grams per mole. Okay, so you can actually, just by looking at this, the molecular formula for the molar mass and the empirical formula molar mass are approximately the same. So when we divide the two out, right, we're going to end up getting approximately 1. So what that means is that the empirical formula is the molecular formula. So the molecular formula for codeine is C18H21NO3. Okay, so what I want to do is I want you to try out, this is from worksheet number 6, question number 1. I kind of just jotted down the information so you can give this a try. So it says a compound has 26.7% carbon, 2.2% hydrogen, 71.1% oxygen. It says the molecular weight is 90. So that is the same thing. Molecular weight is the same thing as saying molar mass. Okay, and it wants to know what's the true formula. So in this case, you have to first calculate the empirical formula, then get the molecular formula. Okay, so give this one a try. Okay, so I went ahead and I did the answer key for this, so we can go through this together. So because we're not given the empirical formula, we have to do that first. So these first steps is getting there. So remember, you have to assume you have 100 grams of the sample. So our mass values are here, they're the percentages. We then find the moles for each element. So we have moles of carbon, moles of hydrogen, moles of oxygen. We then take the smallest number of moles, which was hydrogen, and we divide each of the mole values by the smallest. So that's what I did here in step 3. So we end up getting 1 carbon, 1 hydrogen, 2 oxygens. So the empirical formula is CHO2. That's the first step. So now we're on to the new part. So if this part was confusing, you need to go back and review how to determine empirical formulas, because this is basically a continuation of that. So then we want to figure out our real formula. So how we have to do that is we need the molar mass of the empirical formula. So once you have your empirical formula, we can do that, which is 45.02 grams per mole. And we have to solve for our N factor. So remember, the molar mass of the real formula was given in the question. So this part here was given. So if we take the molar mass of the molecular formula and divide it by the empirical formula, we get an N factor of 2. So essentially we take this, we multiply each subscript by 2 to get our molecular formula. So it's C2H2O4. So this really combines the empirical formula, and then this last part is really the new section that we learned today, which is where you determine your N factor and we can get our molecular formula.